Pinot is a database, but it's a specialized kind of database called an OLAP database. Broadly in the world of databases, you've got transactional databases and analytical databases, right? Transactional databases are concerned with this thing, like this order, this shipment, this user. Analytical databases are concerned with these things. You're usually getting big groups of stuff, like a bunch of orders or a bunch of shipments or a bunch of people or a bunch of clicks or sensor readings or whatever. You want these things and not this thing. And that there we are. Okay, we're clicking now. Just a little bit of historical context there. When I was a younger person and just getting my start in software development, the kind of the modern analytics tradition was emerging at that time. Call of it like the early 90s, the late 80s, the early 90s. There was this idea that there was all this data locked up in these databases in the business, and if we could just gather that together into one place and produce reports, that would be really cool. And that actually was really cool. And the next day, you could have this complete view of what had happened in the whole history of the business from the previous day through whenever. And that was a game changer. Now, getting a report the next day printed on paper does have certain 1990s energy to it these days. That's not how we do things. A bunch of things have happened, right? So that cycle time of batch analytics has had pressure on it. Yesterday is a long time ago. Maybe an hour ago would be better, 4 hours ago or something. And it's not just important people in corner offices that get printed reports, but it's like people on the factory floor, as it were, individual contributors in the business, wherever, whatever that means in the business, need access to analytics products. And you can't wait as long as you used to wait. It used to be, in 92, next day was a game changer when ETL was being invented and all this stuff. It really was, those wild-eyed revolutionaries then, who are old timers now, were causing that change, and it was cool. We need things faster now. Things are, this may surprise you, increasingly our commercial, it's that thing where you have the echo for your own voice and you sound drugged. You know that? I'm clean actually today. So anyway, more. Does Adderall count? So it's prescription, but yeah, more and more of the transactions that kind of govern our lives are mediated electronically, and we just expect these things. You expect the computer in your pocket to wiggle when something happens. That's just how the world is. So there are some kind of use cases that drove this emerging category of databases. Because we've had analytic systems. This is not a new idea, but they've been systems that have data freshnesses of, like I said, like a day. And it might take, I don't know, a few minutes to return a big complex query. And if it's a printed report, that's fine, but it's not fine anymore. Pinot, the actual thing I'm talking about, started at LinkedIn like 6 or 7 years ago. I should know that. But LinkedIn used to be an online resume and Rolodex, right? Like it was professional contacts. Like, why would you go there more than once a month? So for narcissists, they invented this feature that would let you know in real time who has viewed your profile. This is a game changer. Like, I'm on the site all the time now. It's ridiculous. And they needed new data infrastructure to be able to serve this, because these are new analytic queries that are being generated on page load, right? So you don't have, even at this time, maybe 15 seconds would be what a big data analytic system would give you a query. And you have 70 milliseconds maybe, right? Just a completely different kind of thing. Everything in the LinkedIn feed, like every time you go and refresh the page on LinkedIn, there are multiple Pinot queries happening. That's LinkedIn is heavily Pinot and Kafka based, because both those things were developed at LinkedIn. There are other use cases like meal delivery. I think it's kind of true right now that you can't get a meal delivered using any of the major meal delivery services on the planet without there being Pinot queries involved. So we've got LinkedIn and we've got meal delivery. I think we're basically done with the world there. And this is cool. Like if you think about, you want a burger and there are kind of maybe 6 places near you that could get you a burger. The fries never work, right? That's the thing. DoorDash fries, and you got to put them in a toaster oven. But the burger's fine. Maybe you're hungry, like I am now, and you want to know the delivery time of those 5 or 6 burger joints. Well, that's an analytics query. you're measuring that based on many deliveries that are happening right now out of a huge data set. So you have to be able to filter that, get those records, compute the aggregation of those 100 deliveries in the last 20 minutes or whatever it is, and return that result live in the UI. So it's just a different kind of thing. Analytics databases, not new. Real-time analytics database is definitely new. So I want to give you an idea how this thing actually works. I just want to drink water, so I'm going to walk over here and get my water bottle. Hi, everybody. I don't know, you guys. This is a boot camp. Are you boot camp students? Hands, if you, yeah, okay. Looking around, I was thinking that. So we've gotten your feet wet databases. Where are you in the program? Okay, different. Some people are learning could have had like half an hour to talk first. It would have been a lot of fun. Anyway. Okay, well, as a database, you will certainly learn, if you have not learned databases, you'll probably learn Postgres. You'll learn the basics of how relational databases work, and you'll learn about tables. Okay, well, that's just kind of the basic structure of most databases, certainly all relational databases, and that is the structure of Pinot. You have tables. So this is the only slide on the data model. Normally it's a joke, right? I'm like, well, I'm not going to explain to you how tables work. Some of you are like, well, could you? That's because you're getting started, and that's amazing. But yeah, it's just tables. So you learn one database, you understand this. The query language, same thing. Supposed to be a joke. You already know SQL. Some of you are like, no, you're supposed to teach me that. Well, it's the same query language that you're going to use with any other database, and that is great news. There are alternative databases that feel like they need to be special and create different ways of doing this, like MongoDB 12 years ago. It's been a very successful one, right? They're broadly deployed, and boy, if I was an early employee at Mongo, I'd probably be a more relaxed person right now. Very successful company. And they have this other query language that's not SQL. And when you read the docs, it's this little piece of JavaScript code that's the query, and it says, this is like select star from, so they explain it in terms of SQL. So you don't really have much to learn in terms of the API. I want to tell you how it's put together though, because this is kind of cool and it's neat to look inside a database and like, how do you be a super fast database? There are a few things that it needs to be good at, all right? It needs to be very good at ingesting data rapidly, because the whole idea of a real-time analytics database is that there are a lot of things happening, and it needs to be able to pull those things in and make them indexable, queryable right away. So there's high-speed ingest, and it needs to be able to serve lots and lots of queries at once. So a lot of concurrency. If you look at where it was born, LinkedIn, I mean, there's going to be a lot of queries, right? So 100,000 queries a second in a big cluster. We need to be able to pull that off. And like I said, low latency. Now, not all queries in Pinot are going to get done in 70 milliseconds. That's not how databases work. It's just, it can do interesting analytics queries down in that range, and then other ones that are taking longer. For those of you farther along in your database journey, joins are like right now just barely supported, but there's stuff happening that's actually in the main branch. You can clone it and build it, and joins are there as a preview. You can join the Slack community and get more information. There will be a QR code at the end. But like full ANSI SQL joins will be a thing soon. And no, those aren't going to be 70 millisecond queries, right? You can make them be slow, but you can also make them be fast, other kinds of queries. So ingest, concurrency, low latency. Let's talk about how you build one. There's also two ways of ingesting. I can have a big giant pile of stuff that's sitting there and I can suck it in. Or I can have like a pipe of things that are happening and be ingesting those things from that pipe. That second one is called real-time ingest. The first one, where there's a pile of things and I'm pulling it in, is called batch ingest. It's easiest to talk about batch ingest first. So imagine I have this enormous pile of JSON. It happens to all of us, and we have to ingest it. That is going to go into a thing called a table. I already said this because this is the data model. So let's get that into a table. Now, because this is a scalable database, another excellent t-shirt has entered the room. I don't know if you want to get called out on that, but I like that shirt. Also have a very similar one. Because it's a scalable database, you're not expecting to be able to run it on one computer or in one Docker image. like when those of you who are boot camping, when you get started, you'll probably have a Postgres Docker image, and that's like your one little computer, that's your database, and it's perfect, it's great. We can't do that here. We have to be able to spread the data out on many, many machines, potentially hundreds of them. So this table is made up of a thing called segments, and each segment is just a slice of the table. It's some number of rows in the table, all completely self-contained. So as we're ingesting, we got this massive pile of JSON, we're pulling it in. Every once in a while, we'll say, well, that's big enough. Let me just spit out a segment and write that segment to disk. Ooh, what does that mean? Just wait, it's just disk for now. It's just disk. Segments get written to a disk somewhere. Anyway, we're ingesting, we've got segments. Segments are, so here's another really cool thing. If you have a decision when you're being a database, how are you going to store stuff? Well, all right, there's a lot of decisions there, but fundamentally, at the top of this, I have another talk about Pinot. That's Pinot as a choose your own adventure novel, which does everybody know what that means? No. Okay, some yes, some no. Yeah, yes. When I was little, there were a thing. You'd like read a few pages and say, if you want to pick up the sword, turn to page 37. If you want to catch the bird, turn to page 42. It was like the web, but we didn't have the web. So in the choose your own adventure journey of being a database, you have to make a choice about how you're going to store things. So this is a thing, this record. Looks like a click. Looks like clickstream data. Am I going to take, call it a row, that's what we call it a database, right? Am I going to take that row and serialize that and write it to disk as one piece? Or am I going to collect up all of the values of IP, all of the columns, and write those together? Now, you may be thinking, why would any normal person do that second thing? Because it sounds terrible. I regret to inform you that is absolutely what Pinot is going to do. That's because Pinot is an analytics database. Remember what I said, in a transactional database, what are you concerned with? This thing. I want to look up my account. So I need to go send my user ID, select star from users where ID equals 24601. I want the whole TIM record back for that. So that row should all be in one place, right? If it's an analytics database, I don't necessarily want that thing. I want these things, a lot of things all at once. And usually there's like a measurement that I'm interested in. I don't want literally all of the rows. I want all of the values of bytes for this range of rows. So I want a thing on disk where all of those columns are stored together. So Pinot is a column database. Stuff is stored in a segment by column. So for as many of these as I was able to ingest for this segment, all of the IPs are stored in a block, all the user IDs, covered up by Zoom. But Zoom, I love you, and I'm glad you're here, and I'm glad there are remote people, but you have to go away for now. There are indexes. We're not going to talk about these too much today just because of time, but you need to be able to do fast reads of things. And honestly, if you are interested in Pinot and you want to dive deeply, kind of knowing how it's built is a good start. Knowing how to use it, indexes are where the money is there. So you've got different ways of indexing all these column values that help you read them in an efficient way. And any database has indexes, right? If you don't have indexes, what else are you going to do? You're going to go to the first thing. Is this what I want? No. Is this what I want? No. That seems like a bad idea. Instead, you have some efficient structure that lets you say, well, I want, I actually want to know where user ID 24601 is, and I've got this quick way of going through the index, finding it, and that points me to where I am in the file. So the index is stored there. See, I clicked on Zoom, and that means my clicker doesn't work anymore. I have to go back and click on Keynote. All those columns are stored, whatever indexes I have to find on the table, they're stored right there in the segment too, and so on. Segment is just a chunk of table, some row, or some set of rows that I've ingested. All the columns stored together. So if I wanted to reconstitute an entire row now, I'd have to go look here and 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 here. I don't do that very often in analytics queries. It's more likely that I am trying to compute an average of the number of bytes or something like that, or how many times get occurred in queries between 12:06 p.m. and 12:09 p.m. or something like that. So it's just this one thing that I want to measure and aggregate. And so really being able to cruise through this segment and do sequential reads through one of those is a huge win. So that's why it's built that way. You got segments, you got all these segments, and they're all slightly different, slightly different indexes. And if you look at them, they're painstakingly made all the lengths of things differently for different sides. I appreciate your recognition for that. Yeah, it's good. Thank you. I need that. I work primarily for affirmation. They just get numbered and they get stored on a component that we in the Pinot community have named a server. Not a fan, but they're all kind of servers. Look, naming things is hard. You should know this, actually, especially if you're students. There are the two hard problems of computer science. Yeah, okay, nice. Get an audience where it's actually a new joke. This is so good. Okay, the two hard problems of computer science are cache expiration, cache and like when do you kick stuff out of the cache, naming things, and off by one errors. So that's good. Anyway, we can have multiple servers, of course. We can have dozens, hundreds of servers. That's the whole idea. So lots and lots of table data. We get to scale it out among these servers. They have some kind of storage associated with them. If you want to think, just to keep the concept simple, quaintly, of a rack mount box made out of sheet metal that has hard disks in it and a CPU and all that kind of stuff, a server, that's a convenient mental image. Now, whether that aligns with exactly how cloud infrastructure is built in any situation, who knows? But these servers are those quote unquote computers, right? And they're storing the data. Now, we've got lots of them. We're going to, of course, replicate data between them. A segment is never going to be stored in just one place. That's configurable, but you're probably going to store it in multiple servers. The nifty thing about segments is they can't change. And that's another kind of nice thing about Pinot being an analytics database. Once I write a segment, that's stuff that happened in the past. What am I going to do? Rewrite it? That sounds like I'm covering up a crime or something. You can't change that stuff. So once you write a segment, you can throw it away after a certain period of time. You might not want it forever, but you don't need to change it ever. And so a transactional database, writing and updating is fundamental to how that thing works. So the storage subsystem and the way you deal with replication is so much more complex in a transactional database because you're always inserting and updating and not just reading. But in Pinot, you ingest and then you read. Note, we will not talk about this today. Pinot does support a thing called an upsert in certain kinds of tables, which is where there is a thing changing. Like you write it and it is occasionally changing and you're able to overwrite the last value. So that's actually an important feature that gets used a lot and sort of a differentiator, but fundamentally a segment is immutable. You can think of it that way. All right. Gabe said I have flexibility with time. I think I'm really abusing that. So let's just move ahead a little bit. We also have, this is a better word, server, terrible word, broker, great word. So we have one or more brokers, and brokers are where queries come to. So you're a client application out in the world, you send a query to the broker, and the broker has access to metadata. It knows things about the tables and about the ranges of values in the tables. And so it's able to say, to satisfy this query, I need segments 2 and 8. Let me look in my index and see what servers have segments 2 and 8 of this table. And it will scatter those queries to those servers, meaning the same query is going to go to multiple servers in the cluster. Those servers are honestly, they're the heroes of the story here. Okay, they're the ones doing the most of the compute on that query, all of the IO here in these segments. Oh, I forgot to talk about deep storage. Yeah, segments can be basically pushed into a cloud blob store like Amazon S3 or something like that. And why do we do that? Well, it's slower to read from S3 than it is to read from local disk. It's also cheaper. So that is like this infinite sump of storage that I can always put stuff into and never stop, never think about it. And so Pinot will kind of automatically move older segments into deep storage. And when it needs something from one of them, it'll pull it back into the server. It's a little bit of a hit on latency, a little bit of a hit on latency there, but you got this way of being infinite at lower cost, because it would be super expensive to be infinite here. But you can't out S3. That's you're not going to use it all. Anyway, the broker does the scattering of the query. The same query goes to multiple servers. They do the compute, they do the IO. They send the results back to the broker. So it gathers them together and comes up with a unified result to send back to the client. And that scatter gather paradigm, I'm using those words intentionally. That's a pattern that reoccurs in distributed databases over and over again. Not all distributed databases work that way, but it is one way to do that. I have the query, I send it to the places, and then I get the results back and squish them together, and I've got one result set to send to the client. If you look closely at this slide, don't, but it could actually be the case that one server could satisfy this entire query the way I've got it done, which is great news if that's the case, right? You might need to scatter to everybody, all the servers that hold all segments of a particular table. You just don't know based on the query. But these are all running in parallel, right? So you're not waiting for each one of these. You're waiting for them all to finish, but they're not running in a line, so you get faster results at scale. Where are we going? A couple other components, as we're talking about architecture. That metadata comes from another server called the controller that helps kind of manage that metadata. It uses a standard component called Zookeeper. You will see this again. This pops up in distributed systems everywhere. It's super useful. Most people hate it. I don't know why. I mean, I do know why, but I think they should frankly be more grateful. It's done a lot in the last 15 years, and all we do is hate it. But yeah, here it is, Zookeeper, and the controller is helping manage that metadata and also helping with this cluster, right? Like, what if there are 100 of these? They're going to break. You're going to add a new one. Like, where do you move stuff? How do you know where things go? It helps make sure the cluster looks like it's supposed to. It has a picture of what servers should be there, what brokers should be there, and it's trying to create and destroy resources to make sure that that picture stays true. If you really want to read about extra stuff, it uses a project called Apache Helix for cluster management, which is worth knowing. And there you go. I kind of want to take questions, but I also kind of want to talk about indexes a little bit. Yeah, let's just real quick talk about indexes. So the simplest kind of index in Pinot is called the forward index. And remember, the idea of an index, if you're very new to databases, is I've got all this stuff here on disk, and it's extremely expensive just to go through it all. That will waste a lot of time. And on average, if I have n things, it'll take on average n divided by 2 reads to read all those. And that's terrible, like I'm fired. I want it to be much less than that on average. So I have this structure that there's usually some kind of a tree involved, which is a data structure called a tree, that I'm able to see, like, okay, I want this number, it's bigger than this, so I'll go here, it's smaller than this. You can kind of like sort through the tree, and at the bottom it'll tell you, here's the location on disk where that thing is. So I flip right through the index quickly, and then I go right to the thing I want rather than read through them all. Okay, so the forward index is just a way of saying, where is this row? I've got a document ID for this row, and here's the segment it's in. Tell me where it is. So what it's really telling me, not so much as where's the row, but a forward index is defined on a column. So where is the column value for this particular row? I've got a unique identifier called a document ID. It's not called a primary key, it's called a document ID. And that tells me internally the unique ID, and I want to go get the column value for that document ID. And I've got a picture of this. Imagine this is my data, super complex schema. I've got an ID and a city. It's good to start simple, right? It's in CSV format because we hate life. And each of these rows is, I'm giving you here the internal document ID for the row, which is just an internal Pinot way of identifying the row uniquely. So the forward index, what it does, if I have the document ID, it tells me where to go find that location, right? So I get a document ID, I can get a location, and it groups them up. If I've only got, say 20 unique values in the column, it builds a little dictionary, so I'm not storing them all over and over again. I'll give you one or two more index types, and then I'll take a few questions and we'll stop. So the inverted index is a thing that shows up in like text search things. It's very, very primitive text search, but if I've got, the fundamental question is, I've got a value, maybe it's a word that appears in a string, maybe it's just a number, whatever it is, maybe it's just a single word, string, whatever. What rows does this value occur in? So before I knew the row and I wanted to know what the value was. Now I've got the value and I want to know what the rows are. So that's why it's called an inverted index, just goes the other way. So you give it a value, it gives you a list of document IDs. And if you want then to go look up other columns on that document ID, you could use their forward index is good, and you'd be great. So same data, but in this case, the index is the term. And so if I want to know where Littleton is, that's document ID 0 and 1. Mountain View is 2 and 4. Prague, Lucky People is 3, if you get the idea. Anyway, that's those two. No, absolutely not talking about Bloom filters. I refuse. Not doing it. There is a super cool text index that lets you do like fuzzy matches and regular expressions. If you haven't done regular expressions yet, you will. There's the geospatial index. Since Uber is one of the main, they developed this, they made contributions to power Uber Eats. Uber is a geospatial business, so they built this cool geospatial index. All kinds of neat ways to index JSON. You can do like super crazy queries on JSON by building a JSON index. It's good stuff. And that's Pinot. What else can I tell you?